follow the line. Going to apply De Morgan's theorem again. And so we've got a variable z anded with a, or z and y anded together negated. So that becomes what? Z bar or y bar. So this is going to be equal to the variable a bar or b. And then we're going to negate that. Anded with, ORed with, we've got a new variable. What's that variable? A or C bar. There's our variable, but we now have to do what with it? Negate it. Everybody okay with the application of De Morgan's theorem there? All right. Are we done? No. We got to do De Morgan's theorem yet one more time. It's going to get a workout. So this guy is going to be what? A and B bar ORed with what? A bar C. Does that look familiar? Look what we did. We implemented in standard gates using NOT gates, AND gates, and OR gates. We implemented this particular function. I can use only NAND gates to accomplish exactly the same thing. Okay. So back in the day when you were putting physical gates into your design, you could just populate it with a gazillion NAND gates and then you could form anything that you wanted out of that. So using NAND gates, what kind of function do I implement? Give you two choices. Sum of products, product of sums. Sum of products. What do you suppose you could implement with NOR gates? I told you that the NOR and the NANDs are the universal type gates. What kind of a function do you suppose you could implement with NOR gates? So I haven't gone through it yet, but you could take any particular function, and just like we can make a minimum sum of products, we can make a minimum product of sums solution for it. And one may or may not be more advantageous than the other. Most people don't mess with that. They just go ahead and do a minimum sum of products. It seems to be a whole lot more. Questions?
Why doesn't the NAND gate read the way you have it drawn? You have B going into it twice.
Yeah.
Why doesn't that cause a problem, I guess?
Because what is B and B? That was one of our Boolean algebra expressions. B and B is B. Right? Look what happens if you have two switches here. Doing ANDing, my switches need to be what? Parallel or series? Series. Okay? So let me do it like this. Okay. You understand? If both the switches are closed, you're good. Okay, if both the switches are open, you've got it open. Doing all right?
I understand.
Okay. Everybody doing all right? So let me try to show you, I'm not going to hold you responsible for this, but how you would implement a minimum product of sums solution. So let's go ahead with a map here. We'll do 3 variables. Okay, what is the minimum product of some, oops, right. What's the minimum product of some solution for this thing here? Any groups of 8 ones?
No.
No. Any groups of 4 ones? Okay. So I can implement this guy here, and that would be what? We don't have the A variable, it's changing. We don't have the B variable because it's changing. This just happens to be equal to C, correct? Got a lonely one that I need to cover. Can I put it into a larger group though? Okay, I swear on even this first exam, people are going to say, oh, there's a 1 there, and we'll cover it in all the terms. Wrong. Always take a look to see if you can take a 1 and put it into a larger group. Once you've covered all the 1s, you're done. Okay, so this guy can be put into a larger group of that there, correct? So what is that now? This is going to be or
A bar, B bar.
A bar, B bar. Doing okay? Now, to cover this thing in a product of sums, what I do is I cover the zeros and then negate this thing. Okay? So I'm really covering F bar here. Okay, can I put the zeros into groups?
Yes.
Okay, do you see I have a group of what?
2.
2 here. So covering that would be what?
B,
B,
C bar.
C bar. Everybody okay with that? How about these zeros here? A or
C bar.
C bar? Everybody with me? Yeah. Okay. A or C bar? Okay, but I just covered F bar. What I want is F, so I'm going to negate the whole thing.
Dr. Ryan,
Yeah.
are we looking at the zeros at the end?
I'm looking at all the zeros. There are 3 of them that I have to cover. So now, do the negation. Apply De Morgan's theorem on this. This guy becomes what?
B bar or C.
C bar or C, ANDed with
A bar or C.
A bar or C. This is going to be a minimum product of some solution.
So the C plus A bar, B bar was the minimum sum of products?
That is correct. I guarantee that if you do the truth table for this guy here, you're going to end up with this. Which one looks like it would be the less difficult or the less amount of gates, inputs, etc. to implement? They're exactly the same function. Which one looks better to do? This one right here. But I guarantee, sometimes it may be the opposite though. It might be that the product of some solution is easier to do. Most people don't do that. Just go ahead and implement the product of sums and be done. Understand? So I'm not gonna hold you responsible for doing product of sums. You will, excuse me, yes, you will have to do sum of products, yeah.
So this C plus A bar, B bar, that's the MSOP then, or is that MPOS?
That is the minimum product of sums. Excuse me, I'm sorry. Thank you. That is the minimum sum of products, yes.
Dr. O'Brien?
Yeah.
For that loan, oh wait, never mind, I see you after that.
Okay, so, you need more homework?